All right, Integrated 1, I'm so glad that you guys have decided to log on to the video that you're watching. You're going to be glad as well, because this is one of the first things that you start working on in Integrated 2 if you're going to pass my class and move on to that. So this is really not optional at this point. I know some of you have stopped watching videos. For those of you that have been keeping up with the videos, I really appreciate it. But remember, you're doing this for yourself. This is not for me. This is for you. So again, we're glad that you're doing it, but you should be glad for yourself that you're doing it. This last little unit that we're going to be working on for the next, what is it, 5 or 6 more days that we have available together, is tough. It's intense. It requires a lot of thought and understanding, and I'm hoping that you're willing to put in the work and effort. The videos will be longer here in this chapter. You probably have sometimes 2, 3, maybe even 4 videos that you have to watch on those days to be able to get through it. I would try to keep it as brief as I can, but I can't make any promises. I mean, there's a lot of work here, so make sure you keep up with it. Make sure you're doing it. All right, so in order to do this chapter here, you really need some graph paper. Okay, I mean, if hopefully you have some graph paper. Most of you did when we left school. You may want to print out a sheet of graph paper, look, online for, free graph paper, print it out. But some way, somehow, you really need a sheet of graph paper to be able to do this. All right, so anyways, here we go. This is section 25.1, which is on using slopes to classify quadrilaterals. Again, this is pretty hard, okay, pretty tough. So what we're going to do is we're going to look at all your shapes that you learned in the last chapter. And unfortunately, a lot of you didn't do so hot on the test. I don't think you really worked very hard in the last chapter, a good majority of you, and it's going to catch up to you a little bit in this chapter. So let's go back and review the topics that you need to understand from the last chapter to be successful here, and then I'll give you a few notes along the way that are going to help you. All right, so what we're going to have to do is we're going to have to prove that we actually have these shapes. Okay, so we're going to be proving that the shapes are these things. So we're going to be proving that in some way or another. Okay, so how do I prove that I have a parallelogram? Again, this is the last chapter really all over again. Okay, the same topics, the same things. So how do I know that I have a parallelogram? Okay, there were some things that I taught you in the videos that you need to know. What are the things you need to understand that make a parallelogram a parallelogram? What are the properties? Okay, so let's think about those for a second. Well, one of them is that you have opposite sides are parallel. Okay, so opposite sides are parallel. Now, how would you prove that in terms of a picture if it's graphed on graph paper? Okay, the key is in the idea of parallel. How do I know that two things are parallel? And I know some of you like to put your arms up and say they don't cross and all that. Okay, good. But that's not what we're talking about. All right? Parallel here means that they're going to have the same slope. Okay, so same slopes. So how do I figure out that I have the same slope? Well, I count. I count rise over run. I see, do I go up and over the same amount for each set of sides? Okay, that's going to be one of the things that we have to prove. Okay, second thing. How would I know that I have a parallelogram? Well, opposite angles are congruent. Okay? Now, I'm going to tell you right now, that is one that we're not going to have to do, because I can't really prove with what we're doing, you're going to see in a few minutes, that the opposite angles are congruent. Okay? So this is not going to be something that we do. So we're going to say not needed. There's no method needed for that. Okay, third thing. Okay, not only the opposite sides parallel and opposite angles congruent, we know that the opposite sides are congruent. So how do I know if two sides are congruent. Okay, how do I know that two sides are congruent? How do I know they're the same length? How would I check to see if one side is as long as the other? Okay, the way you're going to find that is distance formula. The distance equals the big square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, there's a lot of work in this chapter. Okay, this is where a lot of kids that make it through integrated 1 try to get into integrated 2 next year, and they have some trouble and have a tough time passing even first semester next year, because there's a lot of work. Okay, integrated 2 is not an easy class by any stretch. Okay, so again, we've got opposite sides would be congruent, and the way we would check that is with distance formula. Okay, so we're going to be checking to see if the two distances on the sides are the same. I'm going to be doing this all in just a minute. Okay, fourth thing. How do I know that I have a parallelogram? There was one more thing, something about the diagonals. Did you study this stuff? What was it about the diagonals that was true? Yes, the diagonals bisect each other. Okay, so the diagonals are going to bisect each other. Now, how am I going to be able to tell that two diagonals bisect each other? The idea would be that when I draw it, okay, that this would be congruent to this, and this would be congruent to that. What would be true is that they would have the same midpoint. This distance and this distance would be the same. So this midpoint would be the same as that midpoint. So in order to tell if the diagonals bisect each other, we're going to check to see if they have the same midpoint. And the way we do midpoint is with x2 plus x1 divided by 2, comma y2 plus y1 divided by 2. So we're going to have to check to see if they have the same midpoint. If they do, the diagonals, then we know that the diagonals bisect each other. All right, so here's our first example. Let's see what we can do with this. Again, this is not easy at all. Okay, so please, please, please make sure you're working and doing this in order to be successful. All right, so prove, here's example number 1. Prove that ABCD is a parallelogram. And we're going to go through all of them. Okay, now in the book they might just ask you to check if the opposite sides are parallel. They might ask you if opposite sides are congruent. We're going to do it all 3 ways. Okay, again, we said that we don't need this way, so we're going to cross out 2 right now, but we're going to need to show it with 1, 3, and 4. I'm going to help you with all of those. Okay, all right, so what we need to do first is we need to draw. Well, actually, I need to give you points. Let me give you points first. The points are: point A is -3, 4. Point B is 1, 2. Point C is 3, -2. And D is -1, 0. Okay, so get those points copied down. -3, 4, 1, 2, 3, -2, and -1, 0. All right, so let's get a graph set up. Doesn't need to be real big. The points themselves are not very far from the origin. But let's spread them out so we can kind of see what we're dealing with. Now remember what I've said many times this semester. Looks like it is not enough. Okay, you cannot say, well, that looks like a parallelogram, or that looks like a rectangle. You got to actually do the work for it. All right, so let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Let's plot our points. -1, 2, 3, 1, 2, 3, 4. Now what I like to do when I do this is I like to label the letter and the point next to it, because I'm going to be using those numbers a lot. Okay, so plot the point, label it next to it. 1, 2, over to 1, up to 2. That's point B. 1, 2. Okay. Let's go ahead and plot the next point. Okay, what is the next point? Next point C is (3, -2). Okay, so there's point C, 3, -2. And lastly, (1, 0 is there. There's point D, (1, 0). Okay. Now, does that look like a parallelogram? Yeah. You'll see when you connect the dots, so go ahead and connect. But again, looks like it is not enough to say it is a parallelogram. Okay, you have to do the work to show that it actually is a parallelogram. Again, your integrated 2 teacher is going to expect that you can do this. Okay? Alright, so let's do this. Let's go through how we're going to show it's a parallelogram. Opposite sides are parallel, is what we're going to do. Okay, so are the opposite sides parallel? Okay, well let's check that. So let's start with side AB. So let's do AB and its slope. What is the slope? Well, this is pretty simple. All you have to do is count. How do you go from dot to dot, from A to B? You go down 2 and to the right 1, 2, 3, 4. So the slope of AB is to go down 2 over 4. Okay, again, we've counted slope before. Rise over run from A to B, down 2 over 4. So if I do that, that's (1/2 for the slope. Okay, let's do the same thing for DC to try to see if DC has the same slope. Okay, so again, we got our slope here. So we're going to go down 1, 2 over 1, 2, 3, 4. So down 2 over 4, which is (1/2 there. So those two slopes are the same. I'm going to write it here on the paper. (1/2, slope here, (1/2). Okay. Now let's do the same thing for AD. So again, how do I go from point A to point D? I go down 1, 2, 3, 4 over 1, 2. So the slope of AD is to go down 4 over 2, which is (2). And BC, let's do the same thing. So let's find it for BC now. Okay, so checking BC's slope, we go down 1, 2, 3, 4 over 1, 2. So the slope of BC is down 4 over 2. That's also (2). So the slope here is (2). The slope here is (2). Would you say that the opposite sides, their slopes, are the same? And the answer to that would be yes, they are the same. So since the opposite slopes are the same, the opposite sides are parallel. Is it a parallelogram? Yes, it is a parallelogram. Okay, that's basing it on the sides being parallel. All right, there's going to be a second video. We're going to do this question again, but by a little different method.